All right, so our last special case when factoring, this is called the square of a binomial, right? So if you were to take, a plus b and multiply it by itself, another a plus b, it would multiply out to give you a squared plus 2ab plus b squared. And so the idea is if you notice something in this form, you can just go straight to factoring it like this. This is really just a special case of normal factoring. All right, I'll show you here. So we've got x squared, leading coefficient's 1. Let's go ahead and write that down here. So this has to be an x. And I'm just going to factor this, the normal way first. So because this is a positive, these have to be the same signs. Because this is a positive, they both have to be plus signs. All right. And then here we're looking for two numbers that multiply to give us 36, and they add together to give us 12. So we've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then the last one would be 6 times 6. All right, and those add up to give us 12. They multiply to give us 36. So this could be a 6 and a 6. And because you have something times itself, you could write it as x plus 6 to the second power. Right? That just means you're multiplying it by itself. So what they're saying with this formula is right off the bat, you notice that the first term and the last term are both perfect squares, x times x and 6 times 6. And then you happen to notice that the middle term is equal to 2 times 6 times x. All right, that's the 2ab part right there. 2 times, this is the b, which is 6 times 6 is 36, and then the a is the x. All right. And because you notice that it's written like that, you can write it in this form, where it's the first number, x, plus the second number, the last number, which is 6. All right, that was the 6 times 6 part, and then all of that stuff to the second power. Don't know if it helps you that much, but eventually you kind of get used to it, and you look for that sort of thing. But I just prefer to think of it as a special case of regular factoring. All right, second example here. We've got two binomials here we're factoring into. This has to be an x because the leading coefficient's a 1. This is a positive, so these have to be the same signs. And the middle term is negative, so they both have to be negatives. All right. Now we're looking for two numbers that multiply to give us 16, and they add up to give us 8. So we've got 1 and 16, 2 and 8, and then 4 and 4. That's what does it. So these will both be 4s, which you could rewrite as x minus 4 to the second power. All right. So using the formula, you would have to think of this whole expression like this. Let me write it again down here. You'd have to think of it as x to the second power minus 2 times x times 4. And then it'd be a plus 4 to the second power, 4 times itself. All right. When it's written like this, you can see that it matches this format up here. All right, you have some number squared. All right, and then there's a plus or there's a minus, and then there's a 2 times the a and the b, all right, x and the 4, and then there's a plus sign plus the last number squared, 4 squared. It's kind of an oddball thing, but like I said, you get used to it after a while, and you can just apply it. It's not that big of a deal for now. It's a lot simpler just to remember how to do the normal factoring.